Hello there. In this OSL programming tutorial video, we are going to look at how to create a small practical normal blend map utilizing reoriented normals. So it's very high quality. You won't get the same quality if you overlay, use other kind of tricks or to blend the normal maps. So where did this origin? Well, stumbled over some article on the net. Couple of guys, Colin, Stephen, go over different methods. Bear in mind this is HLSL code. It's not OSL, but it's closely related to OSL in some ways. Most ways. They go over different blending types, overlay, linear blending, showing the shortcomings of the different blend types. And they then developed a new type of blending, which superior, very nice. And the code snippet for the particular function is right here, so we're going to copy that. Go into Max here. Going to create a new shader here. Going to open this one and paste in this code we found on the internet. Going to open this a little bit. Move it over here. This we can close this one down. We have our user interface up here. So and the general idea is that we have two bitmaps. We just pipe it into a blender, put it into the bump node, and we're not going to use the additional bump slot down here. We have two normal maps. So one thing you need to be aware of is that the input needs to be linear. So you would disable auto gamma for your inputs for it to work as expected. And as you can see here, it's working in the viewport, and it's working with Arnold. So everything is nice. Okay, so let's get started. We need to first decouple the version that I already did. We're going to use this checker as a dummy. So let's see it. Let's see here. We need to do two things. We need to encapsulate this into a function. We need to fix some syntax things, and we need to add a shader component so the whole thing will compile. Let's encapsulate this in a function. So we want to make a vector, and we want to have two inputs, a vector A and a vector B. And we're going to make this guy here. We're going to make the opposite direction like this. And we now have a function without a name, so we are going to call it RNM. We have a vector called RNM with two inputs, which are going to be our two color or the two bitmaps down here. So let's try and compile this for the first time. Okay, so it says line 6 unknown struct name float 3. That's because HLSL use float 3. In OSL we use color or vector. So I'm going to just quickly rename everything that's called float 3 in here to vector, like this. And the last one, vector. And it should be obvious that this is a vector between these two guys here, and the component values are -1, -1, and 0. Okay, so what do we need to do now? Let's try and compile again. Okay, text base was not declared in this scope. That's because the guys on the article, they load in textures. We want to load in some kind of just generic color code, which is a vector A and a vector B. You can see here that the T vector and the U vector actually call two different textures here, and that's the textures they are blending with, like this normal here and then the round one. So those are the two normals they go by. Let's see here. Oops, I need to be careful here, like this. Okay, so we don't need all this junk here. This is their input. We want to just say A, and we want to change this to B. So the two textures are now passed through these vectors TU, do some magic down here, and conform to the right space. So as you see here, this U here, this is actually an HLSL. This is just a name. It triggers the U component of position in OSL. So we need to just rename this one, and you need to do that throughout this function here. So and in HLSL, a vector is defined or is called on the single channels by defining them with X, Y, and Z. In OSL, the syntax is a little bit different. It's these two brackets and then 0, 1, and 2. So this should, in theory, compile, and it does. If it says error, no shader function defined, it's compiling. So let me just quickly clean up this stuff here so it looks a bit better. So our first step is completed. The function is now F7 compiled. So we need to build a shader. We call it RNM. We do the same thing with the vector construct. We're now just calling a shader. So now the actual shader construct knows this is a shader. This is our user interface that's in here, and then we have these two guys, and this is where all the meat is. So meat, UI, and this is an external function. Okay, so let's see here. Let me try and compile. It compiled. We have the note down here. It says no valid output. We have no inputs. So let's try and improve the situation. So we do get some inputs. We want a normal A equals 0, and we want it to be a color. And we need to make sure that the normal color that we load is actually a base normal, which is a color that is constructed by these three values: 0.5, 0.5, 1.0. Remember color, comma. We're going to make one more entry. Call this one B. So this should be two inputs, A and B. We also need an output. And we're going to output a color. I'm going to call it out 0. So we should get, since this is a UI entry, we should get three entries over here. We do get that. Normal A, normal B. We get some UI here. So, but we also need a switch per map and a mix per map. So So let's see here. Map A, map B. So under A we need to initialize an integer called enable normal A, and we're going to set the condition to 1. 0 means disabled, so when we load the shader first time it comes in with 1 and then a comma. Okay, so we now have a new entry there, but we also need to tell this integer that it shouldn't be actually an integer. Like here we need a checkbox instead. So by doing that we make these two claims here, and then the other way as well. Move this down here like this, and this is the metadata area where we're going to call a string. This is a widget. The widget should be a checkbox. And let's try and recompile that. And as you can see here, we now have a checkbox. So let's just tick this, copy this, put it down here. All good. And this is enable B. And we should get 2 checkboxes. I'm going to rename this to outdoor. I'm going to signal an area. This is our output area. Okay, so we now have a more complete user interface, but we also lack a mix value. The mix value is a float. Like we want to mix in the two bitmaps. We're going to call this mix A equals, the initial value should be 1, and we need to sort of like clamp this value for the user so we don't get some crazy values here. And the way we do that is by again generating a metadata area here, and we want to call float mean a little equals 0, and we need a float max equals 1. So that means, okay, so the initial value of this mix value, mix A, is 1, and we can only move between these two values. So let's try and compile that. We set parameters. Let's see here. Yeah, I can only go between 0 and 1 with these floats. So we guarded the user from exposing crazy blends. So we want to blend strengths. We want to copy this mix down here like this. Give yourself some room. And of course this one is going to be called mix B like this. Okay, and so that goes, that's basically it for the user interface. So right now if we take the map that goes in here, nothing comes out because we haven't defined anything in the meat down here. We need to define what this output is, because right now it's set to 0, so we get a black box. But we want to inject some data. What kind of data? Well, we want to take this normal map. Want to take this normal map, somehow plug it into this function and exit to out. So how do we do that? Well, we go to the meat here. We first say, well, we want an output. We want what is it? Well, we want to use the function RNM, and we want to use two specific entries here, and that's the color normal A and color normal B. Not vector A and B. These are dummy names. They can be named anything, as long as you reference the same letter or naming down in the actual function. You could pass in something called blip blop, and here could call it chair, and it would work perfectly fine. So we want to pass in normal A and normal B. So let's do that. Normal A, comma normal B, because the rule is that in the function RNM we need two entries. So separated by a comma, because we're going. This is dictating how it how it should look when we grab it. So that's it, and we can try and compile this. There's a syntax error. That's because I forgot the semicolon. So it's compiling, and as you can see, we now have a map here that goes through, and let's check if it's working. It should work, and it's working perfect. So let's go back and hook up this one, and as you can see here, we're good to go. The math or the function up here correctly passes these two entries and puts them out to the output, or sends them out to the output correctly. So we also created some enable state and some mix state we want to add into the equation. So let me just make this window a little bit smaller, something like this. Okay. So what is it that we need to do? Well, we need to make some small useful if then. If something, then we need to do this, else we need to do something else. Okay, so what is it that we need to do? We need to check something. What is it that we need to check? Well, we need to check if this enabled, if this integer is actually enabled. If it is, use the color. Otherwise, use use a base color. So if let's see here, enable normal A equals 1, then we want something to happen. And what is it that we want to happen? Well, we need this entry to be the map. Otherwise, we need the this entry to be a base color, this base color up here. So for that to be a successful experience, we need to create some intermediate nuts. We call them pipe A, pipe B equals 0, and these are colors, of course, and we also need to generate that bailout color if it's switched off. So that's going to be color C equal color 0.5, 0.5, 1.0, like this, and I need to change this to like that. Let's compile that. Alright, so we created a base color now up here. base normal, and let's see here. So if this one is enabled, then we want pipe A to be equal normal A, because normal A is what we plug in here. If it's not hooked, then we want pipe A to be equal C, because C is this this base color here. So let's try and compile that. Let's see if if it returns anything. It does not return anything. It's because we have got to actually say that now this normal A, that we made a more complex scenario here where normal A can have two states, so need to actually pipe in this pipe A here instead, because we renamed it. Or we made another construct with carrying over the different states. So that's pipe A, and hopefully it should work now. Yes, and as you can see, we can now pipe this in and out. So we basically need to just copy this thing here like this. I'm going to call this switch A on off, and we are going to call this one something like this. So if enable B, then in this case we need pipe B to be normal B, else pipe B is C, because we need the same color, so we can just do the same for that one. And we then need to go like this. Okay, let me just quickly clean this up a bit. Something like this. Okay. So let's see if this is working. Enable A. Now it's not there. Now it's there. And then the bricks. Okay. So we basically fix these two, and now we need to add the mix component. Let's see here. So what is it that we need to mix? Well, it's basically these two entries, this one and this one. We need to modify. We need to extend it. So how are we going to do that? A good tip, if we want to upgrade a potential line when you code something, make a copy of it and just dash it out, because you can then go back and check the old one and you know, go back and forth while keeping it. You could have some complex stuff up here you wanted to either pack or unpack or whatever. So this is just a thing to keep in mind. So what is this? Well, we need this normal to be mixed with the C value up here, based on this mix slider here. So and how do we do that? Well, let's see here. We needed to mix. What is it that we need to mix? We're normal A. We need to mix normal A with C, and then what is our mix value? Well, that is mix A. So, but since we need the reverse effect, we need to put a 1 in front here, and then everything should be nice and dandy. I forgot the parentheses like this. Okay. So let's see here. We're going to mix the actual map with this base color based on this mix amount. So let's see if that's working. So it was the first one. Let's check here. Yes, this one is working. Mix 0. Yes, as you can see here in the viewport, it's mixing in. So if we for example didn't put this 1 minus, compile this, then the logic would be reversed. So so that's it. We just want I guess a normal logic, so we put in 1 here. You can sit and fiddle with these things, recompile, pull the spinner, try and put in, just experiment, because that's what I did. I didn't have a solution for everything here when I first started. I just progressed through it exactly like I do in this video here. So so that's fixed. We're going to pick this PyBay here. We're going to do the same thing down here. Comment that out. Remember to rename this one. We're going to mix the B like this. We're going to mix in mix B in this case here. Recompile, and we should have full compliance with the UI. Yeah. So now I'm able to mix in the bricks. I'm able to mix in the noise texture, enable them, disable them, so forth. So and that's basically it. We can try and clean it up a little bit. But that's how you go about it. So we use some if states here to provoke some of the subsettings on the shader here. So I think that's it. I hope you enjoyed the video, and if you have any questions or anything, let me know about it. Have a nice one.